All right, so we are going to talk about functions. So there's a couple of things we'll talk about here. We've got the relation, which is any set of ordered pairs. The domain is going to be the set of all first components of the ordered pairs, which are going to be your x values. You can't divide by 0, and can't take the square root of a negative number. Those two things are going to help us down the road as far as finding the domains. And then the range is going to be the set of all the second components of ordered pairs, or what we know as our y values. A function is a relation in which each element of the domain corresponds to exactly one element of the range. And then, for example, we might see an equation like this, y equals 0.42x plus 10.5, telling us that it predicts diamond production, where x is the years after 2000, y is the value in billions of dollars. So that is a function. We can choose any value for x, so x is an independent variable, and the y depends on the value of x, so y is a dependent variable. All right, so let's go look at a couple of functions. So for example 1, we are going to determine the domain, range, and is it a function. So for part A, we have -3, 7, 1, 7, and 2, 2. We have a set of points. And what we want to do is find the domain. So the domain is going to be all of the first values, or the x values, in our points. So that's going to be a -3, a 1, and a 2. Our range will be our second one, and whenever we have any that repeat, we'll only write it once. So we have a 7 in 2 points. We're only going to write the 7 once. And then we want to know, is this a function? Well, it is a function, and the reason that we know it's a function is that we're going to want to know why. And the why is that you can either put the domain does not repeat, or you can write that the x values, or x value, do not repeat, okay? Because that's what we're looking for. Remember, the definition of a function is where each element of the domain is exactly with one element. So that means it doesn't repeat. Otherwise, if I have 2 -3s in there, then it's not going to be a function because I get 2 outputs. And you'll see that a little more clearly as we look at the second one. So let's look at part B. Here are our points. 4, 7, 6, 10, 5, 5, and 4, 6. So there are our points. So is looking for our domain. Again, that's our x values. We have 4, 6, 5, and 4. So it'll be 4, 6, and 5, because that 4 happens twice. We'll only write it once. And then for our range, we have 7, 10, 5, and 6. So is this one a function? Well, this one is no, because remember, a function has one domain, gets one range, right? One element of that. So if I put in a 4, I get out a 7, and I get out a 6. So because I get 2 answers, it's not a function. There are 2 elements for that x value. So it's going to be no. And the y is that the domain repeats, or you can say x values repeat. So you don't have to do both, just one or the other. Same on this part here. All right, let's go look at example 2. So for example 2, we want to solve for y in terms of x to see if y is a function of x. Okay, we're on there. So if we are given x squared plus y equal to 4, I'm going to solve for y. So subtract the x squared from both sides. I get y is equal to 4 minus x squared. So it's hard to tell maybe from here. So let's plug in a point. If I plug in x equal to 1, then I get y is equal to 4 minus 1 squared. So that'll be 4 minus 1 squared is 1, which will get us 3. So that gets us a point of 1, 3. For x equal to negative 2, I get y equals 4 minus negative 2 squared. That'll get me 4 minus negative 2 squared is 4, which will get us 0. We end up with negative 2, 0. So for each of the numbers I plugged in, I only get one y value. So this tells me, is this a function? The answer is yes. And why? The x values do not repeat. You could also put the domain. So we can state that y is a function of x. Okay? Now let's look at another example of this so that we can understand this concept a little bit further. So this will be example 3. We're doing the same instructions. We're solving for y in terms of x. So we have x squared plus y squared equal to 4. So again, I'm going to solve for my y. You're going to notice that this is very similar to the previous equation. There is one slight difference. Now I still have to solve for y and not y squared. So how do we do that? We take square root of both sides. So taking that square root of both sides, I get y is equal to, don't forget the plus or minus, square root of 4 minus x squared. Remember, we have to put the plus or minus if we introduce the radical into the equation. So our equations are very similar now, except we have a square root and we have a plus or minus here. So let's take and use the same method we had up here. We'll plug in x equal to 1. So that means I get y is equal to plus or minus the square root of 4 minus 1 squared, because we're plugging in that 1 value. Well, that's going to get plus or minus the square root of 4 minus 1, which is plus or minus the square root of 3. So what does this mean? This means that when I plug in 1, I get the square root of 3, and I get negative the square root of 3. So how many answers did we get? We got 2. So because for 1x there are 2 y answers, it's not a function. The function is no, because our x value repeats, or our domain repeats, but to me it's more clear that we're plugging in an x value. It means the same thing. So we would state that y is not a function of x. So here's the clue. On this one, we have y equals. There's no plus or minus. It's just a y equals 4 minus x squared. Here we have the plus or minus. If you get the plus or minus, you're going to get 2 answers. The only difference would be somehow, like if maybe we plugged in a 2, you'd get the square root of 0. So then you wouldn't. But as long as you don't get something like that, it's not going to be a function. So plus or minus, not going to be a function. All right. So for our next problem, This will be example 4. We're going to find the domain. And remember, we had 2 things we couldn't do. We can't divide by 0 and can't take the square root of a negative number. So for part A, we are given f of x equals to x plus 2 over x plus 5. To find our domain, we don't have a square root, but we have a denominator. Remember, we can't divide by 0, so we're going to set that denominator equal to 0, subtract the 5 over, and get x equal to negative 5. So in your homework at this point in time, they're pretty much looking for the domain is x can't be equal to negative 5, but you also need to know how to do it in interval notation. So if we're trying to find that, it's, to me, easier if we graph it first. So I'm going to put negative 5 because that's the number we're dealing with. I'm always going to put my negative infinity and infinity. It can't be this, so this will get parentheses. And then it's going to go this way and that way. So that means we'll have negative infinity to negative 5 union with negative 5 to infinity. This is the interval notation. Okay? So you should know how to do this. But look in your homework to see, like, you can always look and view an example to see what kind of answer they're looking for in there. All right, let's look at another one. So part B, we have g of x is equal to 1 minus x squared. Well, on this one, I see no fraction, and I see no square root. So this one means that the domain is all real numbers, because there's nothing that's going to cause us a problem. Nothing will make us divide by 0. Nothing will make us take square root of a negative. And for interval notation, this will be negative infinity to infinity. Now, when you're doing these, you don't necessarily have to graph them, but sometimes it's easier to see what it is. And again, this is going to be interval notation, just so you understand what that is. All right, let's go look at part C. All right, so our next problem is going to be h of x equal to the square root of x minus 1. So here we have a square root. The square root can't be negative, so what we're going to do is take whatever's underneath the radical, and we're going to make it greater than or equal to 0. Because I can take the square root of 0, and I can take anything greater than 0, just not anything less than 0. So this one will just add the 1 over and get x greater than or equal to 1. So for the domain, they're just looking for this. That would be your domain part right there, x greater than or equal to 1. If you're doing interval notation, again, I'm going to do the graph because I find it easier that way. I put the 1, it's greater than, so it's going to the right. Not because it points that way, but because the greater goes to the right, less than goes to the left. They kind of match. Now on this one, because we have an equal to, we'll get a bracket instead of parentheses, because we can actually include the 1, and it'll be 1 to infinity. Infinities always get parentheses. So again, this is going to be your interval notation. All right, so the next thing we're going to look at are vertical lines. So vertical line test, it intersects only once for a function, more than once, not a function. So if I draw a vertical line through any of these graphs, here it hits twice, here it hits twice, it only hit once, and it only hit once when I draw the vertical line. And you can draw the vertical line on any part as long as it's touching the graph. So not a function is a function, okay? That's all there is to vertical lines. So the next thing we're going to look at is evaluate a function. So example 5, we are going to evaluate a function. And remember that f of x is the same thing as y. So if we now, like we've been seeing y equals and now we see f of x equals, it's the same thing. So if we have a function f of x equals x squared plus 3x plus 5, we want to find f at 2. So f at 2 means we're going to plug in a 2 for each one. So 2 squared plus 3 times 2 plus 5. 2 squared is 4. 3 times 2 is 6 plus our 5. When we add that all together, we get 15. Now let's use the same function, f of x plus 3. So now instead of plugging in a 2, we're going to plug in an x plus 3 for wherever our x is. So we have x plus 3 squared plus 3 times x plus 3 plus 5. Now the one thing you need to remember is that when you have x plus 3 squared, that is the same thing as x plus 3 times x plus 3. So we're going to FOIL this out. X times x is x squared. X times 3 is 3x. 3 times x is 3x. And then 3 times your 3 is 9. It's FOILing, first, outside, inside, last, or just distributing the first value to both and then the second value to both. Combine always your like terms right here. You get x squared plus 6x plus 9. I usually like to pull that out and do it over here so that this doesn't become so messy. All right, but you can do it all in here if you want to. So now we have x squared plus 6x plus 9 plus 3x plus 9, because I still have to distribute here, and then plus 5. So now we'll combine our like terms, and we end up with x squared plus 9x plus 23. And then our last one will be finding f at negative x. So we're plugging in our negative x for our x value. So negative x quantity squared, 3 times negative x, and then plus 5. Remember, squaring any negative makes it a positive when it's in the parentheses there. So that'll give us x squared minus 3x plus 5. All right, so that's evaluating a function. You just plug in things in and evaluate what does it mean. All right, our next example is example 6. We are going to graph a function by plotting points. So f of x is equal to 2x. Just a very simple function. So we've kind of looked at these in the last section. We just didn't kind of figure them out because we were doing vertical and horizontal lines, but we're making a t-chart of x and y. You just need to pick some values for x. I typically don't pick like 1, 0, and -1 because they're so close together. Sometimes it's hard to see what the graph does. So I typically will pick -2, 0, and 2. Not always, but typically. So all we're going to do is plug in that value of x. So 2 times -2, well, that equals -4. 2 times 0 will get us 0. And 2 times 2 equals 4. So we're just plugging these values into our function to get our y values. And then we'll graph. All right, so for the x's, we really only need 2's, and for the y's, we need 4 hash marks. So 1, 2, 3, 4, 1, 2, 1, 2, 1, 2, 3, 4. All right, so at -2, we are at -4. At 0, 0, and at 2, we are at 4. And trying to make my line as straight as I can and hit my points. Again, it's just a sketch, so I don't expect perfection. All right, so the next thing we're going to do is we're going to look at some pictures of graphs and see if we can determine the domain and range. So we have some small versions are on your handout, so you can look at those. I'm going to pop up some bigger versions so that we can look at those. It makes it a little bit easier to see. So we're looking at this first one. So our domain, we want to look at the domain, the range, the x-intercepts, and the y-intercepts. And we're going to find a given function value. So here we're looking at a parabola. We've got arrows going in both directions, so our domain is going to be negative infinity to infinity, because that's our x, starting from here and going over, both arrows. And then our range starts, domain starts from left to right. The range starts from the bottom up, because we're going to start with the negative values. So we're coming from the bottom, which is going on forever, so it's going to be negative infinity all the way up to 4. So let me pull our writing paper out. So this will be example 7. So for our domain, we are looking at negative infinity to infinity. This will be for part A. And then our range was negative infinity to 4, and 4 gets a bracket because it includes the top part of our graph. And then we are, because it touches, the next thing we're looking for are the x and y intercepts. So our x-intercept is where it crosses the x-axis, so it's going to be at negative 2 and 2. Typically, I would suggest that you write these in point notation. So we're going to put it as negative 2, 0, and 2, 0. And then for the y-intercept, that's where it crosses the y-axis, it's up here at 4. So it will be 0, 4. Again, also in point notation. And then let's find our function at the value of 1. So we're just looking at the graph. So if I look at the x value of 1 and I go all the way up, it equals to 3. That's what you're doing. It's just looking at the graph, figuring out the point means. All right, let's look at graph B. Let me get my other pen. So B, we're again looking for the domain. We're looking for the range, the x-intercept, and the y-intercept. So our domain goes from, again, from x, or from the left side to, on the x-axis, left to the right. We start at negative 2. It includes it, and it goes all the way to 1. It also includes it because it has closed circles. So it will be bracket, negative 2 to 1 bracket, because it includes both numbers. Now we're going to do our y-axis, go up to find our range. We're coming up from the bottom. And as we come up, the first spot we hit is where our range is at 0, and it stops at positive 3. Again, it will also have brackets because both are closed points. The x-intercept, we only have 1. It is at negative 2, 0. And then the y-intercept is at 1. So it will be 0, 1. Okay? All right, and then let's look at our third graph. So on our third graph here, we are looking again for domain, range, x intercept and y intercept. We're not going to do each one to have a function value. I just wanted to make sure you knew how to do it. The domain is going to start again from the left going to the right. So first we hit -3, but it's an open circle, so it means it's going to get a parenthesis. It does not include it. It goes all the way over to 2. It's closed, so it gets a bracket. The range will come up. We're at 1, but it's open, and we stop at 2, and it's closed. So it'll be 1, 2 with a bracket. There is no x-intercept, and the y-intercept, we'll call that about 1.5. It really, as long as you're kind of in the ballpark, I'm okay with that. So it'll be 0, 1.5. You could put 1.7 if you wanted, whatever, works for you. Because those are kind of sometimes hard to guess if they're not right on the line. All right, so that takes care of looking at graphs and determining what's going on with the graph. All right, so the next thing we're going to look at is the difference quotient of a function. So the difference quotient of a function is f of x plus x minus f of x over h. And h cannot be equal to 0 because remember, we can't divide by 0. One of the things you need to know is when you go into Business Math 2, you're going to use this a lot. This is how we find derivatives. So you really need to understand how to do this one if you're going into Business Math 2. All right, so we are on example 8, and we are going to evaluate and simplify a difference quotient. All right, so here is our function. F of x equals 2x squared minus x plus 3. So the whole difference quotient is doing this. We're going to do this in pieces. We're going to first find this part, then we'll find the top part, and then we'll find the whole thing. So the first step we're going to do is we're going to find f of x plus h. Now, if you recall, we were doing some evaluating our function. If you remember, we were doing things like this earlier. We evaluated at 2, we evaluated at x plus 3, we evaluated at negative x. This is doing the same thing, except we're going to do x plus h. So it may seem a little like weird looking, but we've already been doing some of it. But some students really struggle with doing the h part. All right, so that means what we're going to have is f of x plus h equals 2 times x plus h squared minus x plus h plus 3. So that's all we're doing is just plugging in the x plus h. Now again, I've told you before, when I have these, I pull them off to the side. So x plus h squared, remember, is x plus h times itself. That'll get you x squared plus xh plus xh plus h squared. And it doesn't matter if you write xh or hx, it's the same thing. And if one's written as xh and the other one's hx, it's the same because it's multiplication property. So those two terms are going to combine. So x squared plus 2xh plus h squared. Now this one's a little different because we have a 2, so we're going to put that in parentheses because we got to still multiply it by 2. And then distribute that negative sign. So now we have 2x squared plus 4xh plus 2h squared minus x minus h plus 3. Now that's this part. Now what we want to do is find f of x plus h minus f of x. Well, we already have this part found, and f of x is the original function. So this is going to be equal to 2x squared plus 4xh plus 2h squared minus x minus h plus 3 minus our f of x function of 2x squared minus x plus 3. Now, I always put that in parentheses because we've got to subtract the whole thing. And remember, this answer is just coming from this. So let's distribute our negative sign. So we're just rewriting all of this first part. So minus 2x squared minus plus x minus 3. Have that double negative there. Now, this is typically what will happen. Everything that doesn't have an h should cancel. So the 2x squareds cancel. The negative x and positive x cancel. The positive 3 and the negative 3 cancel. So we are now left with 4xh plus 2h squared minus h, because everything else is gone. Now we'll do the very last step. We will find f of x plus h minus f of x all over h. Well, we've already found the top part now. We have 4xh plus 2h squared minus h all over h. So what we can do here is we can factor out an h. On the top, we're left with 4x plus 2h minus 1. Don't forget the 1, because you factored it out. It doesn't go away. All over h. The h's cancel, and we're left with 4x plus 2h minus 1. Now, you don't have to do it step by step. You can do it all at once, but it can be a little bit easier to do it this way so that it's not quite so bogging as far as all of the processing. All right, we have one more problem to work. Let's talk about some business functions. So I've kind of put some stuff in here that you might need to know. Cost function, C of x, or C, we've talked about that previously, is the total cost of producing X items. It's going to be the fixed cost plus the variable costs. So like A plus BX. Or you can look at it as Y equals MX plus B, however you want to look at it. Profit is P of X equals the total amount left after the costs are paid. That's how much you make, the profit. That's going to be the revenue minus the cost. So however much you bring in minus how much it goes out. Revenue is the total amount from sale of however many units. And the revenue is the number of items sold times the price per item. So it's the number of items, which will be your X, times your price. And then price demand is going to be P of X is equal to the price for X units demanded. P is equal to M minus NX, where X is the number of items that can be sold at so many P dollars per item. So those are some functions that you might see like in the text of your homework. All right, so a manufacturer of a digital camera wholesales the camera to retail outlets throughout the United States. The price demand function is P of X equals 94 minus 5X. What is the company's revenue function for this camera? List the domain, and then find the revenue if 3 items are sold and if 6 items are sold. Alrighty. So this is going to be example 9. We are given our P of X is equal to 94 minus 5X, and I forgot to put this part into the handout, that we are looking at going from 1 to 15 items for because your X is your number of items. So for part A, we are writing a revenue function, and we got to find the domain. So remember that the revenue function is equal to however many we sell times your P of X, the price. So this is going to be X times our function up here, 94 minus 5X. So that'll get us 94X minus 5X squared. So that's our R of X. And then for the domain comes from what we are given here. It's going to be from 1 to 15. All right, and then part B. For part B, we are asked to find the revenue if we sold 3 items. That's R at 3. So we're going to plug in 3. We get 94 times 3 minus 5 times 3 squared. This will get us 282 minus 45, which will get us 237. And it's revenue, so it's dollars. And then R at 6 is equal to 94. Plug in our 6 for the X. 96, or 94 times 6 minus 5 times 6 squared. That'll get us 564 minus 180, which will get us 384. So those are what we're looking for using those revenue and price functions. All right, make sure you do your homework.